Greetings. Would like to welcome you again So we have a speaker here, Miss Elif Boncuk from Garanti Teknoloji. She's going to give us a speech regarding the app optimization. So would like to welcome her to the stage, please.
Thank you. Welcome all. I am Elif Boncuk from Garanti Teknoloji. Today I am going to talk about Android application performance, some common performance issues and how we can solve them, what kind of tools we can use. Actually, wait a minute. Okay. No.
Then you accidentally close your presentation. Get back to desktop, please. There is a folder.
Okay. Okay.
So we have your presentation in here, in Galata. It should be, I guess, it's here. Tower. So we have
Optimization, yes. Okay, thank you. So who am I? I have graduated from Hacettepe University at 2011, and since that time I have been working on Garanti Teknoloji mobile applications team. By the way, it wasn't mobile application team when I was first started. It had a different name, but we had an application, Garanti Android. And I'm a mobile application developer, not only an Android application developer. We write for every platform at Garanti Teknoloji. But my love is always on Android. And also, I am an MBA student at this school. I'm a blogger. You can follow my posts. And current member of Garanti Bank Photo Club. So let's start. Application performance is always a big issue for all of us because someone says and comes to us and says that your application is too slow. Firstly, we have to use some profiling tools to gather data and then examine this data to gain insight and finally find the problem and fix it. This is a bothering process. So what should we do? Actually, if we know how the system works at first, we can know the right things to code. I divided the steps into 4 major pipelines. I start with rendering, then compute, memory, and finally with battery. Rendering, I think, is the most important one. Designers always want from us the most fancy and transcendental applications for user experience. But on the other hand, it can't work like this because some devices, such as not so strong ones, it can't work at the same performance at every device. And sometimes the devices could be locked by application, the screen could be locked by the application. This is not a nice experience, actually. Firstly, the system will redraw your application at every 60 milliseconds. It means that the images, the graphics, all the things on your activity will be redrawn at every 16 milliseconds. So it hits 60 frames per second. And you should complete your whole work at this 60 millisecond window. But what happens if you can't complete your job at this window? So it's called dropped frame. For example, if your work takes 24 milliseconds, then the user couldn't see the update after 60 millisecond window, and the user could see it after 32 milliseconds. Even if there is one drop frame, the application won't be so smooth, and if there are lots of drop frames, then the users will start to complain about your application, actually. And we can think about rendering a device into two main pipelines, the CPU and GPU. Measure, layout, record, and execute operations is done on CPU side, and rasterization is done on GPU side. At the CPU side, the main problem is unnecessary layouts and invalidations, and GPU side, the most common problem is overdraw, is wasting your GPU time. So how does your activity get drawn to the screen? Or in other words, how do the XMLs and markup languages turn into the pixels so the users can see and understand it? This is called rasterization. The high-level objects like strings, buttons, firstly turn into the polygons and textures by CPU, and then it's passed to the GPU, and thanks to the rasterization, we can see it. But for both CPU and GPU sides, they are not so fast processes. And if we have to change some things, the operation will start from the very beginning. Thanks to OpenGLES, once the content is created by CPU and uploaded to GPU, if we need to reach the content in the future, we can reach it very fast. But as I said, if some changes is done on visual parts of our view, the process will start from very beginning. It's a waste of your GPU and CPU time. So if we want our application to be faster, we shouldn't do visual changes as long as possible. And overdraw, as I mentioned before, you see the screen, there is a stacked structure, and we see only the top one, and it hides other views. If we draw the views that we won't see, then the GPU time will be wasted. And how can we understand there is we did something wrong? There is an option at developer options menu, debug GPU overdraw. When we open it, your screen will start to like this one. You see on the screen there are lots of colors, and it's normal. Actually, each color has a meaning. The true color is no overdraw, blue overdraw once, green overdraw twice, pink 3 times, and red 4 or more. Actually, blue one is acceptable, but red is very bad for user experience and performance. So how can we pass from the red ones to the blue ones? Firstly, we should eliminate unneeded backgrounds and drawables, and if we can, we should define the areas will hide portions of the view. And clipping is the best optimization is done by Android application system, actually. Android system knows that overdraw is a real problem, and it optimizes it. But when we write custom views and override ondraw, then it won't be work. The system won't know if the view will be hide or not. At this point, Canvas class will help us. We can use clip rect method to define the drawable zone, and quick reject method to control if the area is on the drawable zone or not. All the things that I talked to here is all about GPU optimization. If we move on with CPU optimizations, firstly, you see on the screen there is a button, and to see it on the screen, firstly, a display list is created and then executed by the CPU. And this display list have all the information that needed by the GPU. If we do some changes on our view, this operation will start very beginning. It means this playlist will be recreated and executed and passed to the GPU. And also, it changed according to the what we have done actually. There is a sample on the screen. We have doubled size of the button, and then you see a text view here. It shifted, and the parent view size has changed. At this situation, the measure method will be called, and layout also because of the positions has changed. Actually, these are very fast operations and handled by Android system. But as I said, if we write our custom views and don't use the right methods, then it would be a problem. And we can understand if there is a problem or not while using hierarchy viewer. It actually simulates our view structure and help us to flatten our structure. When we use hierarchy viewer, the output will be like this you see on the screen. I think the most important property of is the bird's eye view. You can see the whole structure of your screen. There is a tree view and tree overview. When you move that gray airport, which is on the tree overview, you can change the area you see on the tree view. And by clicking view properties tab, you can see the selected nodes properties. Also, if you double click the nodes, then you will see the view when the user will see it on a pop-up. But you can't go to the source code because you see the current screen at this point, not the whole structure. On the other hand, it gives you the IDs, and you can go to the source code and find the problem by using the IDs. And another very important, I think, property of hierarchy viewer is relative view performance. When you select a root node and to compare the relative child views performance, just clicking this button at the top, you will get the result. There will be three nodes actually. The left one represents the draw process, and the middle one layout, and the right that represents execute process. There will be three colors, green, yellow, and red, and each has a meaning here. Green means the view renders faster than at least half of the other views. Yellow means the view renders faster than the bottom half of the other views. And red means the view is among the slowest half of the views. At here, red is a normal color because it's a relative performance, and yes, we weight red ones, yellow ones, green ones, all of them. But if there are lots of red ones, then there would be a problem. For example, 20 plus, we should check. And second topic here is compute. Compute is important because all the process, the execution of the source code, etc., works on our device. So we have to look for the compute and our function performance. If we start with slow function performance, there are two kinds of slow function actually. The first one is the simple one. You see there are one function, and we know that there is a problem. Our function is slow. So what should we do? We can find it and change it. It's okay, it can be done. But the second one is more complicated because there are lots of functions. For example, 10,000 functions we have, and every function works slower than for example, 1 millisecond to the normal. At this point, to find the problem and fix it is a bit more complicated. At this point, we can use some profiling tools from Android, and it will help us. For example, TraceView, we can use it. It uses debug class to log the tracing information. Once we use TraceView, the output will be like this. There are two panes, timeline pane and profiling pane. At timeline pane, you will see some threads, and each bar shows a method. And according to the width of the method, we can say that it takes too much time or not. Once you select the method, also you will see it on the profiling pane. And also, if you select a method on profiling pane, then you will see it on the timeline pane. And there is a nice property of profiling pane, search filter. You can use it. And batching and caching, also they are very important, all in all this. And threads. Thread is very important. Once your application is started, a thread also created, we say it main thread, and all the things about your application is kept on this main thread. Also, we can say this UI thread because this is the thread your users interaction in. For example, your user clicked the button, then UI thread dispatch the touch event, and then we set its state as selected, then request to the queue. UI thread take this request and notifies the button, and finally it updates itself. And as you see on the last image, touch and render and update operations sharing the same cycle. And if our touch event takes too much time, then the update also will be after a very long time. So how can we solve them? The main thing to do is here to define the operations that we do not have to done on main thread. For example, if the user clicks the button and then we send an email, it doesn't have to be done on the main thread, actually. It could be done on another thread. But the important point is here, Android system is not thread safe. It means that you can trigger UI thread from the worker thread, but you shouldn't. There is a single thread model, and we should obey these two simple rules. Do not block the UI thread, and do not access the Android UI toolkit from outside the UI thread. As you see at this sample code, yes, there are another thread, a worker thread. It takes the images, load images, but this is wrong because the update of the image view is not this worker thread. So how can we do? We can use views. For example, post method here, and then the update operation will be done on the UI thread. This is a solution, and very nice solution, but on the other hand, there is a more cool solution, actually. You can use async tasks. The sample before I mentioned, we don't hold the process. We write the worker threads, updated the image, everything. But at async tasks, actually, there is a method doing background, and worker thread is works here. After the operation has completed, the post-execute method will be called. I didn't write here, but there is also another method, pre-execute, and if you want to do anything like something you prepare to input, you can use it. And also another nice tool, systrace. You can get timing information using this trace, and it's very simple to use. As you see on the screen, trace.begin section and trace.end section, you can put your code between these methods, and also you can take information about the timing. Once you use the systrace, this is a bad performance application example you see on the screen. And how can we analyze the systrace output? There will be frames you see on the screen. The color of it, green, red, or yellow, as always. Green is okay, but if there are yellows or red, it means that you missed the 60 millisecond window. And also, it gives some offers to the users. When you click the view, as you see, bottom part of the screen, there are some offers that you can use. Also, top right on the screen, there are alert stops. It can warn you. And third topic is memory, of course. Memory is all about, actually, garbage collection. There are two basic principles of garbage collection. Find the object that we won't use in the future and reclaim these resources. It's okay, and it's a cool thing, actually, but it could be dangerous also. For example, if we allocate 10,000 objects at the same time, the system can't know which ones are deallocated or not. So we can use, at this point, memory mentor. This is the first step. It helps us if our application is crash from the memory or another problem. The dark blue shows the currently using memory, and the light blue is unallocated memory. This is a sample of a problematic memory monitor output. As you see, there are lots of allocations, and after a little time later, there are deallocations. Okay, we know that there is a problem, and we don't know where it is. Then we can use heapweaver. Heapweaver output will be like this. There are methods that are allocated on your system. Once you select a method, there will be a histogram on the bottom side, and it shows number of allocations, object size, and also we can see the count of the allocations, total size of the allocations, and we now know that there is a problem and which method causes this problem. And but on the other hand, we don't know the exact location of the problem. After these two tools, we can use allocation tracker, and we can find the exact location of the problematic code. And today's last topic is battery, of course. When we take a Nexus 5, for example, and it takes it to the standby mode, the battery output will be at the first images. And if we awaken the device, then the output will be second. And if a job awaken the device, for example, an alarm clock awaken the device, then the output will be at the top one, at last one. At here, battery stat and battery historian tools can help us. Battery stats take data from your device, and battery historian converts it to the HTML format so we can understand and we can use the information. The output will be like this. It gives us lots of information actually. For example, the top shows us the top running application. It will be our application. CPU running, Wi-Fi running. There are lots of information. You can get more information about androiddeveloper.com. And also, if you save the battery stats.txt file, while searching on this file, you can get more information. For example, if you search per PID stats, you can take how long each process ran. The problem here starts with actually when our device is on the sleep. There is a application, it's awaken our device. Okay, now it's doing its work, and then the device will sleep again. But how long it take? If the work is too simple, too minor, but it takes too much time, then the battery will be drained at this point. And this is an output from Google I/O 2014 project Volta. There is a problematic screenshot actually. As you see, there are lots of gaps. This is not normal. So how can we handle this? Actually, we can use WakeLock API. It gives us some opportunities, but it's not gives us the whole what I need, because there are two problems here. Once timeout, for example, Wi-Fi cut down or another problematic situation is happened, how long we should wait? And another one is, okay, it's cut, but how should we wait after take another try? At this point, we can use Job Scheduler API. There is a service component in it. We defined it, and we override on start and on stop methods. At the on start method, excuse me, we check network connection, we do our job, and on post execute method, if cut from Wi-Fi or another problematic situation, we call the job finish and release the object. And as you see, post server method has changed. There is a minimum latency, override deadlines, network type. If we use Job Scheduler, it will be more easy, because at this time, all the logic will be handled by Android system itself. And thank you for all you coming at this rainy Sunday morning and listening Android performance. By the way, we have a booth on the exhibition hall, and we have people from HR. They are very willing to answer your questions about Garanti Teknoloji. If you have any questions, I can take here. Okay.
I have two questions.
Okay.
I'm not them. Are you using OpenGL for applications? What is the advantages and disadvantages of OpenGL? And should applications after not quit, doesn't reloading the data slow down the font?
Okay, as our first question, the system uses OpenGLES API on by on. I only explain how the system works, and after the Honeycomb Android 3, it will done like this. And could you repeat your second question, please?
If the user doesn't exist the app, we should dispose the all data or doesn't loading them slow the load.
Okay. Actually, it's all about your decision. It can be changed about the application, if we need it or if we don't. If we need it really, if there are another option, we can do. And there are books here to the questions. Your book will be here. Are there any other questions? Okay.
Hello, my name is Emre. I would like to ask for new developers. It's my first time listening Android programming. I would like to ask which platform is the better one. You know, Android Studio is going to better new, and I see you are coding in Eclipse. Which one is better platform?
Actually, these are Android Studio. It's all about your choice, but if I were you, I prefer Android Studio because there has been an announced and they said that we don't give support to the Eclipse until this new year. So Android Studio is better. Are there any other questions? Okay.
When I think about optimizing, I think about code optimizing.
Yes.
How can you make iterations more faster, better? How can you improve them? I use, for example, Lean as an
Yes.
code analysis tool. Do you know any other static code analysis tool you use or you can recommend?
Actually, we have used Qualcomm Trepan application, but there are lots of other tools. I only mentioned the top ones, Androids. I think that's all. Thank you.